Before we do any regression, we want to test to see if the correlation is significant or not. And there's a couple different ways to do this, but what we are testing for our hypothesis statements is if the population correlation coefficient, which we use rho, equals 0 versus the alternative hypothesis that rho does not equal 0. And so don't use p, use the actual Greek letter rho for your symbols. When we have here in a scatter plot, let's say there's an x-axis and a y-axis, and we have all of our dots in a perfectly straight line going uphill, we could actually then estimate those dots right in there with a regression equation. And our goal is to see if there's a relationship between x and y axes here. And when we get all of our dots in a nice straight line so that they line up like this, we're going to have a correlation equal to 1. If they were all going downhill in a perfectly straight line, we'd have a correlation of -1. So for instance, if I have my dots going downhill from left to right, this downward trend, r would be equal to -1. Now the slope doesn't matter. For instance, I could have a line that's perfectly together, dots going like this. That would still be r equals 1 compared to maybe something that's really steep, but still all the dots in a straight line. It's still r equals 1. So it's talking about the strength of relationship is how the dots line up in a line. For example, if I was to look at some different values for r, as these dots get more and more scattered, your r is going to get closer and closer to 0. So here's some examples of different values. And you'll see here that they're going uphill from left to right. We have r equals 1. So in this case, perfect linear relationship between those. This is still an uphill trend, somewhat in a line, but the dots are more scattered. So here your r is close to 1, but not exactly equal to 1. As they start getting more and more scattered, here they're more scattered than the previous picture. This is an r equal to 0.5. And so our goal is, as you go on the negative side, it'll go from -1, here's r equals -0.9, r equals -0.5. As they get more and more scattered all together, your correlation gets closer and closer to 0. If you had a scatter plot, for instance, that looked like this, very spread apart, not really apparent up or down relationship here going through, your r would be close to 0. I'll put this squiggly equal sign. It's not going to be exactly 0 unless all of the dots line up in a straight line, flat across horizontal. But there's no obvious upward or downward trend to this, so our r will be close to 0. So remember, for our notation, r is your sample correlation coefficient, and rho is your population correlation coefficient. That gets us back into our hypothesis statement, right? If rho equals 0, that's the same thing as saying that there's no relationship between x and y. And the alternative hypothesis does not equal 0, that's saying there is a relationship. So in order to do regression, when we're talking about correlation, we want to reject the null hypothesis.